Hi guys, let's look at the next question. But before we start the next question, let's revise what we did on our previous video. We realized that in case of complementary angles, sine of one angle is equal to cos of the complementary angle. Similarly, cos of the angle is equal to the sine of the complementary angle. Tan angle is equal to cot of complementary angle. Cot angle is equal to tan of complementary angle. Cosec of an angle is equal to sec of the complementary angle, and sec of an angle is equal to cosec of the complementary angle. So sine and cos are interchangeable, cos and sine are interchangeable, tan and cot, cosec and sec are interchangeable for complementary angles. Let's look at the questions now. Express in terms of angles between 0 degree and 45 degree. So the values given are 68 degree and 72 degree, which means I will need to write them in the form of a complementary angle, because the complementary of 68 degree would be 22 degree, and complementary of 72 degree would be 18 degree. So let's just write this in the form of complementary angle. So this would be cosec. Instead of 68 degree, I can write this as 90 degree minus 22 degree. So all I have done is change 68 into 90 minus 22. And similarly, cot, I am changing 72 as 90 degree minus 18 degree. Yes, 90 degree minus 18 degree. And cosec 90 minus theta is equal to sec theta. So this is equal to sec 22 degree plus, and cot 90 minus theta is equal to tan theta. So plus tan 18 degree. A reason for this, since cosec 90 minus theta is equal to sec theta and cot 90 minus theta is equal to tan theta. So these are the two reasons, and that's why this gets converted to sec 22 and tan 18. Next, let's look at question number 5. Very interesting question. From the exam perspective also. So for triangle ABC, show that sine of a plus b upon 2 is equal to cos c upon 2. So we are looking at a triangle ABC, right angled, at which point doesn't matter. So let's first look at the sum of three angles. So angle A plus angle B plus angle C is equal to 180 degree, which means A plus B is equal to 180 degree minus C. If I take C on the other side, let's divide both sides by 2 and I get A plus B upon 2 is equal to 180 degree minus C upon 2, which means A plus B upon 2 is equal to 90 degree minus C upon 2. Now let's take sine of both sides, which means sine of this angle, which is A plus B upon 2, is equal to sine of angle 90 degree minus C upon 2. Let's see how it works. In this case, left hand side remains the same, which is sine A plus B upon 2, and sine 90 minus theta changes to cos theta. In this case, cos C upon 2. Reason, since sine 90 degree minus theta is equal to cos theta. So this is what they wanted us to prove. We've already done that, so hence proved. Done. Let's look at the next question. The next question that we do is question number 6, part 1. So it says 3 times sine 72 upon cos 18 minus sec 32 upon cosec 58. I notice 72 and 18 are complementary and 32 and 58 are complementary. So let me change the numerator in the first term. So this becomes 3 times sine, instead of 72, I write it as 90 degree minus 18 degree, and the denominator remains cos 18 degree. In this case, instead of 32 degree, let me write 90 minus 58, because 32 degree is nothing but 90 minus 58. The denominator remains cosec 58 degree. Now this becomes 3 times sine 90 minus theta is equal to cos theta. So this is cos 18 degree. The denominator is cos 18 degree minus sec 90 minus theta is equal to cosec theta. So this becomes cosec 58 degree upon denominator is already cosec 58 degree. Reason for this is since sine 90 minus theta is equal to cos theta, and the second one is cosec, no, not cosec, sec, we've changed to cosec. So we've changed sec to cosec. So sec 90 minus theta is equal to cosec theta. So the numerator and denominator is the same, so gets converted to 1. This is the same, so this is this 1. So 3 into 1, that's 3 minus 1, which is equal to 2. So that's my answer. Next question. The next question we do is question number 6, part 3. Says sine 80 degree upon cos 10. So again 80 and 10 are complementary. Similarly 59 and 31 are complementary. So let's just convert. Last time we converted numerator. This time let's convert the denominator. So sine 80 degree upon cos. Instead of 10, I will write this as 90 degree minus 80 degree, because 10 is nothing but 90 minus 80. And sine 59 degree dot sec, instead of 31, let me write this as 90 degree minus 59 degree. 31 is nothing but 90 minus 59. So this becomes sine 80 degree upon cos 90 minus theta is equal to sine theta, will become sine 80 degree plus sine 59 degree dot sec 90 minus theta is equal to cosec theta. So cosec 59 degree. Reason, since cos 90 minus theta is equal to sine theta, and the second one was sec 90 minus theta is equal to cosec theta. So these are the two reasons, which means sine 80 upon sine 80, that's 1. So this is 1 plus sine 59 degree multiplied with cosec is nothing but 1 upon sine, because cosec is the reciprocal of sine. So this is also 1. Reason, since cosec theta is equal to 1 upon sine theta. So this is 1 plus 1, which is equal to 2. So that's my final answer. Let's look at the next question. Very interesting one. Question number 6, part 5. So cosec 65 degree plus a minus sec 25 degree minus a. So till now we've had questions where these two angles were complementary. Let's check if these are complementary. So let's add them. 65 plus a plus 25 minus a. This gets cancelled. This is 90. Yes, these two angles are complementary, which means I will still need to write them in a manner that they look visually complementary. So let 65 degree plus a is equal to x, which means cosec x minus sec 25 degree minus a would be 90 degree minus x. Yes? Yeah, this will be the same, because this is nothing but 90 degree minus 65 plus a, which means cosec x minus cosec x. Reason, since sec 90 degree minus theta is equal to cosec theta, which means these two terms are the same, which means this is equal to 0. So the key in this question was to figure out that 65 plus a and 25 minus a are complementary. After you realize that, there is nothing in this question. Let's look at the next question. The next question that we do is question number 6, part 7. It says cot square 41 degree upon tan 49 degree, tan square 49 minus 2, sin square 75, cos square 15. So 41 and 49 are complementary. Similarly, 75 and 15 are complementary. So we can write this as cot square 41 degree upon tan square 90 degree minus 41 degree, because 49 is nothing but 90 minus 41, and this is 2 sin square 75 degree upon cos square 90 minus 75 degree, because 15 is nothing but 90 minus 75. So this is cot square 41 degree upon cot square 41 degree, because tan 90 minus theta is equal to cot theta, minus 2 times sine square 75 degree upon sine square 75 degree, because cos 90 minus theta is equal to sine theta. Let's just write this reason. Since tan 90 minus theta is equal to cot theta, and cos 90 minus theta is equal to sine theta. So these are the two reasons, which means this is 1. So this is 1 minus 2 multiplied by 1, that's 2. This is negative 1. That's my answer. Let's look at the next question, part 9. 14 times sine 30 degree plus 6 times cos 60 degree minus 5 times tan 45 degree. Oh, I think this is a question from the previous chapter which they put in this exercise. These are standard angles and we know their values. So we know sine 30 degree is equal to half. We know cos 60 degree is also equal to half, and we know tan 45 degree is equal to 1. So this is 2, 1, 2, 7, 2, 1, 2, 3. So this is 7 into 1, that's 7, plus 3 into 1, that's 3, minus 5. So this is 10 minus 5, and the answer is 5. So the value is 5. Next question, triangle ABC is right angle at B. Find value of this given. So let's just draw a rough diagram and see how it works. So it right angled at B. This is A, this is C. So let A be equal to X. C is equal to 90 minus X. These are complementary. So since angle A and angle C are complementary, what this gives me is sec A dot, instead of sine C, I will write this as sine 90 degree minus A. Yeah, C is equal to 90 minus A. That's fine. Minus tan A multiplied with, instead of tan C, I will write C is equal to 90 degree minus A. So let's just write this once again for clarity. A plus C is equal to 90 degree, which means C is equal to 90 degree minus A. Let's just write this. So instead of C, I have written 90 minus A. Instead of tan C, I have written 90 minus A divided by sine B. Now this is sec A dot sine 90 minus theta is equal to cos theta. So this is cos A plus, not plus, minus, between them is a negative sign. So minus tan A multiplied with tan 90 minus theta is equal to cot theta. So this is cot A upon sine B is 90 degree. So this is 90 degree. The reason we need to write, let me just write the reason. The reason is since sine 90 minus theta is equal to cos theta and tan 90 minus theta is equal to cot theta. So these are the two reasons. Now we know sec is equal to 1 upon cos. So this is cos A upon cos A minus, we know cot A is equal to 1 upon tan A. So this is upon tan A, everything divided by sine 90, which we know is 1. So in this case, this is 1 minus 1 upon 1, which is equal to 0. Done. Let's look at the last question of this chapter. The last question of this chapter that we do is question number 8. So question number 8 says find value of angle A, where angle A lies between 0 degree and 90 degree, and a relationship is given which is sine 90 minus 3A is equal to cosec multiplied with cosec 42 degree is equal to 1. So we know sine 90 minus theta is equal to cos theta. Yes, sine 90 minus theta is equal to cos theta. So this becomes cos 3A multiplied with cosec 42 degree is equal to 1. Yes, this is fine, which means this is sine 90 minus theta is equal to cos theta. This is fine. And this is cosec 42 degree. So this becomes cos 3a multiplied with 1 upon sine 42 degree. I don't think this is helping me in any way, because then I am left with cos and sine on both sides. So one side is cos, one side is sine. So let me just redo this question. I don't think this is working for me. Let's try this again. Let's not change this. So this becomes sine 90 degree minus 3a multiplied with cosec can be written as 1 upon sine 42 degree is equal to 1. This looks far better. So I cross multiply. What I get is sine 90 degree minus 3a is equal to sine 42 degree. The reason for the previous step, since cosec theta is equal to 1 upon sine theta. Yeah, that's fine. We started the question wrong step that I did. Well, doesn't matter. We came back to the right method. So this is sine 90 minus 3a multiplied with converting cosec into 1 upon sine. I get sine 90 minus 3a is equal to sine 42 degree, which means 90 degree minus 3a is equal to 42 degree, which means 3a is equal to 90 degree minus 42 degree, which means 3a is equal to 48 degree. Therefore, a is equal to 16 degree. So we didn't need to convert sine 90 minus theta into cos theta because that was not getting us anywhere. We just had to convert cosec into sine so that we could take sine on both sides. Perfect. Next, cos 90 minus a multiplied with sec 77. Again, this is already reciprocal of cos, so I don't need to convert this into sine. This is cos 90 degree minus a multiplied with 1 upon cos 77 degree is equal to 1. The reason, since sec theta is equal to 1 upon cos theta. Let's cross multiply. This gives me cos 90 degree minus a is equal to cos 77 degree, which means 90 degree minus a is equal to 77 degree, which gives me a is equal to 90 degree minus 77 degree. Therefore, a is equal to 13 degree. Done. That finishes this video as well as this exercise for me. Before I leave, let me mark some homework questions for you. So homework for you would be question number 5 part 2, question number 6 part 2, 4, 6 and 8. Yeah, that's about it. 5 questions. Thank you so much. Take care. Be safe. I'll see you with the next chapter. Bye bye.